Hello. There's a few people today, so hello everybody who's here. We finished this week's lab already, so I can still answer questions about it if you have questions about the lab, and if you have questions on Project 4, next week's lab, the C++ boot camp, anything that you like, I'm happy to answer questions about. Or if you want to see me sort of spin up a couple of small examples to help you get started on Project 4. Everything is sort of open. So this is really just time for you to get your questions answered. Since we worked through the lab on Tuesday, and the reason I did that is because I wanted to give you time to get some extra questions in and finish strong on the fourth project if you wanted to do that. So anyway, actually I should say open for questions. Uh, yeah, so we'll deal with that first. I think I saw that Nate's here. Nate, if you're here, I sent you an email from your email. Uh, okay, so let's just sort of get the obvious stuff. And we'll call this. Let me make a folder for this. Today's May 14th. Okay, good. Um, so anyway, what I'm going to do is just kind of script out what the function should do. So it should create the vending machine items, and then it's going to have a loop. This is at least one way you could do it, but again, just so you kind of know the sequence of steps to attack it. So you're going to have to create your vending machine items, and then you're going to have to enter a program loop where you print the items. This has a lot of similarities actually to the spreadsheet because you select some functionality, have a user select an item. Um, and then of course if they selected an item, then I'm kind of showing it like a um, outline. So switch on selection. If they selected an item, then how many? Check stock. If available, add to cart. Now this is just one way to do it if you're like doing a shopping cart and so I call it a vending machine, but you can also do it kind of like a store. So they put items in a cart and they check out, which is the version I'm doing right now. So they select an item, you ask them how many they want. You should probably do this first, by the way. All right, so anyway, they check it. If they select an item, make sure that there are some available. Ask them how many they want, add that number to the cart. Um, all right, so there's one possibility. In checkout, show total owed, collect payment. Uh, this is going to need to be a loop. You need to make sure that you're getting the full amount of payment. So show them how much they owe. collect the payment, and then at the very, very end, show the receipt. So that's kind of the a recipe for it. Now this is not really a vending machine. It works more like a store where you put items in a basket. But it's one way to do it that makes the job a little bit easier because you only have to worry about the checkout process once. Um, so a vending machine item, uh, you need to use a struct here. So why not make a struct? Every item's going to have a name. It's going to have a price and an amount that's in stock or a quantity. So probably all that makes sense. Um, and then we're just reusing I mean, I'm literally just going to rewrite the same code from the spreadsheet, basically. Except for instead of slices, I'm going to use items. So, um, do you want to give it a number? Sure, let's give it a number as well. Let's give it a name and a number, like an item number, so that you can print that in the display. So make a method, which you have to do for the requirements. You can call this whatever you want, but I'm modeling off the describe that we've done. So to describe an item, basically I want to printf, I want to show the number, followed by a dot, followed by the name of it. And then I'm going to clean this up, but then I will follow it with the price of it. And then maybe in parentheses I'll put how many are in stock. Notice, by the way, I don't even have any items yet, but I don't need items to do this because I can already imagine that I'm going to want to print out the item's number, the item's name, the item's price, and the item's quantity. And that right there gives me enough to, I might even do this. Let's just steal this idea as well. And I'm not really describing what I'm doing because I'm just repeating the same stuff that we've done in lab this week, which is, this is just like new movie, except for its item now. So the first field is the name from the parameters. Second field is the number. You have to go in order, so the same order top to bottom is left to right. So the name followed by the number. That comes from the parameter, followed by the price, followed by the quantity. All those are parameters, which allows me to then to build my new item. And then I can describe items. So now I can create some. I can say like I'll show you two ways to do it. So you can do new item. I'll make soda be item 1. I will call it soda. I will make it be worth about 50, and let's just say that I have like 10 of those on stock, in stock. Put chips in there. That's another new item. Item number 2, chips. I don't know how much those cost. Let's say $1.25, and let's just say I have 2 bags of those left. And then put them all in a slice of item. But what I'm going to show you here is that you can sort of eliminate the middleman. You don't need to create these separately. You can just eliminate the middleman. And just make the items right inside the slice and never even have the separate items. So usually when I do that, I'll sort of do them up and down. So there's machine is a slice of item which starts with 2 items. You would need more, of course. Okay, a program loop. Oh, look, these all lined up on me. Oh, that's okay. Um, so I'll just leave those down there. So a program loop. Um, print the items. So cycle through the machine, print out each item. Then I'm also going to want to put like a checkout option. So this, you have to imagine, oops, that's in the wrong place. Way in the wrong place. So you have to imagine that this is the menu. That's the menu. Now for now I'm just going to run it and see what it looks like real quick. What's the problem? This type item. Oh yeah. This is a slice of star items. It's a tricky one. Slice of star item. String. Why? What? Name. Oh, I put these in the wrong order. So what it's telling me here is I used a 1 in the first slot, but that doesn't actually come first. It's the name, followed by the number, followed by the price, followed by the quantity, followed by the number. Okay, so those are just in the wrong order. Okay, so that's to be expected because I have it in a loop. I just wanted to see if it printed them out, and it looks all right. Doesn't look brilliant. I'm going to take this loop out for now and just work on my display. I want to get the display right first, so I want things to line up prettier than they are, so I'm going to actually the item choices is fine, but I didn't like the way this string worked out, so I'm actually going to put it inside of a field of 10 characters wide. The price, I'm going to do the same thing. Let's see how that works. So you can actually take a %s and put it inside of a 10 character field, which will spread it out. And you can also do the same thing with a float. So that's a 10 character field and then 2 decimal places. I'll show what that looks like. So that's better, although I need to put the checkout. So the 10 character field is why it did that. And then that guarantees that they line up real pretty. And then this also, although I hate the $sign being there. So I'm probably going to take a pass on that one. No field. Yeah, that's better. And then what else am I going to do? I'm going to move the checkout over, so the checkout, yeah, that's fine. I can live with it. No, what I should have done is this. I should have modeled it the same way. So that's just a little programmer's trick to put the checkout in a 10 character field, which will line it up with the items. Didn't quite work out. Why is that 10 not working out? Oh, it did. It did. What am I talking about? There, they're all lined up to the right. Yeah, okay. Yeah, not loving that. But anyway, there is some kind of alignment, and that's just really something to work on. Not thrilled. We'll survive. Well, that part's on you. They do line up to the right, but I don't love it. Let's try to make that negative. Let's see if Go will do this. and then we'll get to the meat. Aha! Negative made them line up to the left, and that looks pretty darn good. Okay. So anyway, you might focus on how I put it. Putting a negative there left aligned the characters in a 10 character field, and then I did the same thing down here for checkout. I caused it to be left aligned in a 10 character field, and I'm pretty happy with that. Okay, so I'm not going to do all the details, but anyway, you have this loop out here, which for now I'm not going to do. Well, maybe I'll put it back so you can see where it belongs. Okay, so this is the main program loop. So I show them the menu, and then I'm going to ask them what they want. Get what they want. Now there's some cool ways to do this. So once you're in a slice, um, you sort of have to imagine when they type choice number 1, that's actually item number 0 in the slice. And choice number 2 is item number. So what I can do is say if the choice, I'm not going to use a switch. If the choice is 0, then start the checkout process. Otherwise, if the machine, so that choice is going to be one more than the item's number in the machine. So if the machine choice minus 1 dot quantity is 0, then they get an astigram is sold out. And what that hole is for is to take machine at choice minus 1 and print its name. So the thing to look for is every excuse you could possibly have to use the struct and its fields and the slice, you can save so much coding work. Else, how many %s do you want? There's the name again, so I can say how many sodas do you want, or chips do you want, or whatever, something like that. That's a bit to start. You may want to sort of, before I overload you with stuff, that's sort of a couple of initial ideas. And then you have the sort of recipe here, which when I saved it, it all got itself lined up, but it's the spreadsheet again. Show them all the options, figure out what it is they want to do. It turns out that in this case, there's only 2 options. There's either the checkout process or they're buying something. And if they're buying something, you don't need to write a whole bunch of extra code if you're smart about using the slice and the struct in combination. You just take what their choice is. One less than that is the index of the item they picked in the machine. And then you can just use that to start plucking stuff off, like the quantity. So that's sort of a starting point. Right from here, you would reduce the quantity of the item and then add the amount of the item to the cart. If you have cool software, you won't let them pick more than you have available, but that's something to sort of think about. How could I do that? The other thing that you might want is a cart. I personally would use a struct for that. Where you can, there's a couple of ways you could do it. One thing you could do, you could just add it to the item if you wanted. Yeah, do that. Do that. Um, if you keep track of how many of an item they've purchased as part of the item, which when you make a new item you'd say 0, um, then when they go to the checkout process, you can still use the machine that knows how many of an item they purchased. And notice how I updated new item to 0 that particular piece of information out for everybody. So that's a lot, and I worked fairly fast, but um, that's a starter. It's actually mostly done already, except for um, some logic. So I'll just give you a quick hint here. So total owed is determined by arranging over the machine for items and say total owed plus equals, so it's the I dot purchased times I dot price. So that's a really easy way to use the purchase field to compute how much they owe you, is just sum up. That's the sum of all of the, how much of each item did you buy, times its price, and then you collect payment. I don't know why it went all caps. You collect payment. You print a receipt. And then you break. Okay, that's a fair amount, actually. If I go much further, I will have written the whole program. So I'll stop there. Sort of having seeded a few ideas, but um, the bouncy ball? Yeah, I will. So Tyler, I can come back to that, but now that's sort of captured in the video. So when I upload the video, that'll still be there, and you can go sort of study over it. I did things kind of the fancy way, meaning I tried to take advantage as very much as I could of the slice and the struct all at once, and then sort of to show you where I would do things. So this is actually almost done already, minus the irritating part of handling the human being who's going to try to mess it up. Okay, I'm not sure where to leave that. So you can tell me, I can re-show it later, but I'll go ahead and go look at Amanda's question about the bouncy ball, which is a fun one. Okay, so I'm about to hide that window with the vending machine idea in it and go bring up a browser. I've got it all spread out so that we can do some Replit stuff. The bouncy ball. So let me go to the final lab, which go. Okay, so that's probably programming challenge 1. Yay! Okay, this one's fun. No problem, Tyler. And just I can restore that, but again, you can probably just go kind of capture that 10 minutes of video later if you want and study up what it is that I've done. And plus, we still have all of next week, and we still have Wednesday next week if you want to pop in and ask me to clear up something. Okay, so the bouncy ball. What are we supposed to do? Declares a class named ball with the following. Property color, size, and then a describe and a bounce function. Oh, this one's going to be fun. Okay. Um, so, I've got my Replit running. Let me make sure that you can see my Replit running. Okay, you can. So I'm about to wipe out everything that I did the other day and start with the fresh one. Okay, so BIP, it's all the way except for I'm going to put this return 0. So Go doesn't have this on func main, but that needs to be the last thing that happens in main. Okay, so a class. A class is very much like a struct. It's just the setup of it will look a little bit different. But a class is very much like a struct, and in that you put properties inside of it, and then you have methods. Or in C++, we pretty much call all of them functions. Um, but they're kind of like a Go method. So class uh, ball. In C++, you have to put a semicolon down here, so just be very, very careful of that. That you get that semicolon on there. You don't have to do this in Go. So this is kind of like type ball struct, except for in C++ you put more stuff in here than you would in Go. Okay, so you also have sections. I'm going to do public first. So in C++, you kind of have to have it in your head that we're talking about something that's very much like a struct, um, uh, where you have properties which usually go in the private section. For us, that's going to be what? Color, which is string, and size, which is string. So string color, string size. Uh, the arrangement of things is very different. In fact, can I can't conveniently do it. Um, I'll go do the same thing. Actually, you can tell me as we go if you want me to stop and sort of show you what this would look like and Go, or I can do that after the fact. Um, but if you can kind of imagine that this is type ball struct with color string, size string inside of it, that's basically where we're at right now. C++ does everything with more work and more overhead and more complexity, so that's just a fact of life there. And what are the functions? Describe and bounce. Boing, boing, boing. Okay. Describe. I'm going to copy this and bring it over so I can remember what it is it's supposed to do. Okay. So methods in C++, we can put inside of the class. So this is like a method in Go, except for in Go we separate it from the struct. In C++ we can actually embed it into the thing. Now I'm going to have to fix that, but I brought that over so that I could use it as a template. And it does look like a mess. It's true. It looks like a mess. But this is basically how C++ does what we've been, it's what the C++ version of what we've been doing with structs now for a couple of weeks. Describe and then bounce was the other. And then I'll slow down a little bit. I'm going to squeeze this so I have more screen real estate for you to look at. Now we're not finished, but that's getting pretty close. So notice that, by the way, that's all one unit of code. All of that stuff we just did is inside of these two brackets that mark the class ball. So a class in C++ is very much like a struct in Go. It's just the way it's arranged is slightly different. So you have properties for a C++ class, and you have methods for a C++ class. They're just set up slightly different. And we can look at this as in a Go version here in a bit if you want to do that. But I'm going to pause and make sure you have a chance to catch up. Why are things overlappy? Oh, no, that's okay. It's all right. Well, a class is just one way in C++ of organizing code. So when we say a block of code, we usually just mean a section of code that's marked by curly braces. That technically that's all a block is. So that's a block. That's a block. Main is a block. This is a block. A class is a way to, it's an organizational unit of code. So a class in C++ is a way that you capture um, properties and methods. And maybe if I sort of bring up a Go version so you can sort of see what this would look like in Go, and then I'll sort of drag it over next to it. So let me see if I can do that. So I'm about to hide this for a second so that I can. Okay, so let's see. Let's put this over on this side and shrink it just a hair. Okay, so let me show you what this would look like in Go. So we can sort of compare the two side by side. So type ball struct. We have a size, which is a string, and a color, which is a string. Um, so that's the stuff that's in the private section of the class. And then in the public section, the way we do that, and let's not use stars right now. Let's just say ball. What did I call that? Is it describe? Describe and bounce. Okay. I am a size color ball. Okay. And then in a second I'll hide this and we'll go back. Boing boing. I'm gonna go copy that because I don't feel like typing that whole thing. Okay, so this is what that same code, that class, looks like in Go. You have a struct with two properties in it, and then you have two methods. So in C++, you'll notice that the property, so here's the class that ends way down here. So you have the properties inside of it in this private section, which is typical. And then you have the methods inside of it. I think that the way C++ does it is messier, and for some people harder to track until you've practiced it for a long time. But that's the equivalent Go code next to it for what we have, although I need to put a main in there. Oh, wait a second. Let's not do private for now. Let's take that private out. It's going to make life a lot easier. We take that private out. Hold on. Sorry, I got to switch over and function that. Okay, yeah. Let's just have the public, and then the properties and the methods go under that public labeling. Let's get rid of that private labeling. And then there's where the ball class ends. So hopefully that. See the character on the end part of your code. Let's see which character. Let me look at my character. Oh, let me get rid of the open for questions. Sorry. Okay, hopefully that helps. I didn't have forgot about that. Oh, is that what Nate's asking about? Okay, yeah, so she's right. This is ENDL. So it stands for end line. End line. ENDL. Yeah, that's not a 1, which is what it could possibly be. ENDL. Okay, so let's touch up both. So I'll do the go one first. So what we would do with size is we would poke a hole here for a string, and then poke a hole here for a string, um, and then we'd say b dot size, b dot color, right? And then we do the same thing here. So size, poke a hole, color, poke a hole, b dot size, b dot color. But anyway, we don't have to do tons of the Go. I just wanted you to show you that that's kind of in Go how we would do the same thing that we're doing in C++. And I mean, if you ask 100 different people, you probably get a whole bunch of different of opinion about which one they prefer. Um, I like the way Go does it, but I've worked in C++ enough that I'm used to it, so it doesn't bother me. You can, yeah. Atom's just a text editor, so you can write a basically anything in any language in Atom. So it's not particular to Go. You can write anything. So yeah, if I wanted to, oops, if I wanted to in Atom, I can just show you. I can take that same code, this code here. I can paste it into Atom. What you'd save it as is .cpp, which stands for C++. Well, you can't see that part. But anyway, you can save it with .cpp, and then notice that Atom colors it up for C++ language. So yeah, the reason why we're working in Replit is because we can immediately run it from here, which you probably can't do on your computer. Okay, so I don't know if that helped, but maybe it helps a little bit just to kind of see what would be comparable in Go. Um, I'll put that on the ball.go side. Okay, so let's swap those back around and deal with the C++ some more. Okay, so we need to poke holes here, and this is significantly more difficult than C++, at least the standard way. So we got to poke a hole. And we're going to have to poke two holes. But anyway, let's put the, so in C++, you just put size here. So now it says I am a stop, switch to size, ball, but we also need to poke a hole for a space after size, and then we need to poke a hole for the color, and then ball. So that's a lot harder to work with. But anyway, this is what we were looking at yesterday a little bit. With these C-outs, they take practice because they're such a mess. At least they look like such a mess at first. So every time you switch, you have to put another one of these in here. So I put a string in there, and then I put the size variable in there, and then I put a space in there, and then I put the color in there, and then I put the rest of the sentence in there with the space before ball. And we're going to have to do the same thing down here. This one is going to get nasty. Size. And what I'm going to do here is I'm going to roll it over to the next line. Which you're allowed to do, and C++ is a lot more forgiving about this kind of thing. Go doesn't like it when you do weird formatting, but C++ doesn't actually care. So anyway, there's the boing, boing, boing goes the being output, and then I switch to put the size output. Then I switch to put the space output, and then I switch to the color variable. Then I, oops, take that word out. Then I switch to ball, and then I put the new line. Anyway, so that's kind of a pain to deal with. Those COUTs, and it's until you've gotten some muscle memory, you're gonna make mistakes and you're gonna get compiler errors. Um, so there's still a bunch of you here, so that's good. The thing to know, we're doing the C++, we're getting a head start on the C++ boot camp, barring other people's questions. So this is C++, and just sort of be careful about the semicolons. We don't use those almost ever. Well, just in a lot fewer places in the Go language, so just be careful about the semicolons. They're required. So void is that's how in C++ we create a function that doesn't return anything. So in the Go language, the way we do a function that doesn't return anything is we simply just leave the spot after the function empty, right? So if we wanted to return something in Go, we'd put what we intend to return after the function name. And in Go, if you don't intend to return anything, then you just leave that section blank. But in C++, if you don't intend to return anything, you actually have to put void, which means I'm not returning anything. Hold on. This is a community college class. Okay, sorry I got puzzled by that for a second, but it is someone coming in and looking intelligent. Okay, if you're in my class and I just blocked you, then please let me know by email, I suppose, and I can unblock you, but I don't want the distraction of strangers coming in and then I'm trying to figure out what they're asking. Okay, so anyway. Um, yes. So the main in C++ is always int main. That's a good question, and yes, it always is. It's always exactly like that. Okay, so let's go on to the next part, and then as questions come up, just feel free to ask them. So now in main, we're going to create a ball called ball1, and then populate it with some data, and then describe it and bounce it, and then a ball2. Okay, so I can do that. So this is a little bit different. I mean, it's the same idea. Hold on. No. So for main, so like in Go, it's always func main, and it never changes from that. And in C++, it's always int main. So um, we call that the entry point of the program, and that always has to be set up as int main in C++. Okay, so let's make ball1. So that's a little bit different than we do it in the Go language. Right? In Go, we'd probably end up doing something like this. And then we sort of just, there's other ways to do this, but probably what we do is we'd make ball1 like this. And there is a way to do this in C++, but we're going to go with sort of the old school way of doing it in C++. There is a newer school way to do something that looks like this. But let's do it old school style. So that's how it would look in Go. So that's kind of what we're going after in C++ now. So the first thing you have to do is make the ball, declare the ball, and then So notice here, by the way, that we use the dot syntax the same way that we do in Go. So that part's kind of reassuring. My replet is in the process of acting funny, so I'm going to wait for a second. Yeah, I'm having the same issue. That's fine, I'll redo it if it needs to. I had to refresh mine too. Maybe. Let's see how much it kept. Not all of it, but most of it. Um, ball1.color equals red. Anyway, so C++ also has the dot notation that we're used to, the dot syntax. And then we can do ball1 dot describe and ball1 dot bounce. Kind of the same way that we would fire off methods on a Go struct. The main difference is that we create the ball like this. Although I think technically we can probably say equals. I don't want to get us going down that road because I'm not sure if this one will support that or not. I'm going to run this, see if it describes my ball and bounces it. And then notice how it's using the red and the large in the outputs. Integer. So good question. Yeah, this is an int is an integer. So in C++, um, the main function returns with a code, and by tradition, if the main function returns with a 0, that means it ran to completion without any errors. And sometimes people will write C++ programs that return different codes, which signal to people that the program ran but something went wrong. There's different ways of doing that in Go, but that's why that's that way. Is main returns an integer code after it's completed executing. Oh yeah, I have it hidden. So there's my C++ output. And the thing to note there is that it's using ball 1's size and color, large red ball. If you're doing this alongside me, check your formatting because a lot of people will accidentally leave out some spacing and stuff. And it's good practice to get that right. I'm going to go ahead and make a second ball. And this time I'll do like a small gold just for the heck of it. And then I'll describe and bounce it. And then we'll see in the output, there's the large red ball describing and bouncing, and then here's the small gold ball describing and bouncing. So it's different, but I think you agree. There's a lot of familiar things in there, and it's kind of what you're doing is smart, which is just to notice what looks different, and then try to get a handle on why it's different. But there's a lot of similarities. So the dot syntax Classes do look kind of crazy at first, but they're just a different way of organizing structs and methods. Go has a slightly different way of doing it. Um, you have to type a lot more characters. Yeah, the class is hard. This is one of the more difficult things. Uh, but I also figured, so sometimes when I taught this class, the first semester class in C++, we'd start basically with this stuff as you've seen. But I thought for your class, since we have just been doing structs for a couple weeks, that you might have a little easier time understanding. I thought you would transition well into this particular set of C++ challenges because you have the structs and methods as a reference point. The couts, I think, is the biggest pain in the rear to transition to. And then all the semicolons, lots and lots of semicolons. So if you put, I'll show you real quick the difference. If I put private down here and then try to run it, I'm going to get errors. So I'll get a whole bunch of errors, and notice that it'll say like size is private, color is private, size is private, color is private. So if you put something inside private in the class section, then in the main section you can't get to it with dot notation. So we could switch that around even. We can make those public and make the methods private, and then we'll get different errors. So this time, like describe is private and bounce is private. So what it's complaining about is that I'm trying to get to describe and bounce from the main section, but since they've been declared to be private to the ball class, you can't do that. So these sort of tie these things down to being inside. It's some people debate whether or not this has a whole lot of value. Go actually does have this facility. It just you need to work in bigger software to sort of experience it. So that's what it does. If you make it private, then you can only refer to it inside of this class. And what you'll see, though, is that what most people teach in terms of C++ is that the properties are usually private, and usually most of the methods are public. But since this is a first project, first lab challenge when I'm teaching it, I usually make everything public, which eliminates that confusion. Yeah, and in fact, by the way, if you get rid of public, by default everything is private. So unless you have the public label in there, it assumes it's private. So you actually have to have the public label in there to be able to access it anywhere outside of this block of code. Uh, yeah, in a way that's true. That's not a bad way to think of it, is that public makes it global and private makes it local. Yeah, that's a very good way to think of it. C++ also has structs, by the way, which we're not going to deal with, but yeah. So C++ has multiple kinds of loops. So I'll just leave the ball alone and we'll put some loops in here. In fact, let's bounce the ball a couple of times. So C++ has for loop, while loop, do while loop. It has three different kinds of loops, four different kinds of loops technically. But let's just start with one that you're familiar with from Go, which is the for loop. Um, I'm going to bounce the ball a bunch of times with this loop. So notice the parentheses here. And C++, the counting loop looks like this. Let's bounce it like 5 times. So for the most part, this will look familiar to you. That's a counting loop to do something 5 times. So I'm just going to bounce ball 1 5 times. So that's the C++ version of a for loop. And then I'll run that just to make sure it's still functional. So there's the large red ball bouncing 5 times in a for loop. The Go language has taken all of the different sort of looping ideas and captured them in a single construct, which is for loops. So you have lots of different Go for loops, but C++ has actually different loops. So that one probably looks familiar, but let's do, what do we want to do for a while loop? We'll do a while loop for bouncing the small ball. Okay, so you also have a while loop. Go doesn't have one of these, but probably you recognize, you have a sense of what's going to happen here. We have this count, starts at 0, and then we say while count remains less than 0, bounce ball 2, and then increase the count by 1. So eventually the count will no longer be less than 10 and the loop will stop. So that's a while loop. I don't know if I could do input here. I guess we could try. So again, Go doesn't have this. We just set up a for loop in a different way when we want something that's like a while loop, which I think was a good choice that they made in the Go language. Let me see if we could do any inputs. I wonder if we could do inputs. We'll try. This is very rare in C++, but this is like a forever loop in Go. It's not very rare, but I don't typically teach this in C++. But we could do it. Let's do it. Bounce it again, and then we'd say something like, ask him a question. Here's I don't know if this will work in Replit. We're about to find out. So I know I'm going a little fast on this, but this is a couple of different examples of a while loop setup. So this is kind of like the forever loop in Go, and then this while loop you would set up as a for loop in Go. I'm not sure if it's going to let us do this in Replit, but basically this is a scan line. And then we'd say if again equals no, then we would break. So we have the break statement just like we'd use in Go. I don't know if that's going to run. Let's try it. Oh, it did. There you go. It worked. So this is input, keyboard input. I don't know why they call it, you put a C on there, but that's the standard input device, which traditionally is the keyboard. Okay, so in Go, only for loops, but a whole bunch of different setups. In C++, we have for loops, we have while loops of different sorts. We also have a do while loop, which we don't have in Go. Let's reuse that count variable. So there's three different kinds of loops in C++, and then there's another sort of newer arrangement of a loop, but um, this is not a good place to try that one out. These are sort of the traditional um, loop types in C++. You have a for loop. Where did I put the for loop? Which you'd write like a counting loop in C++, in Go. It's like a counting loop in Go. So for the most part, that looks familiar. You have a while loop, which would in Go you would just set that up as a for loop without using the word while. Um, but that's a loop. So while the count is less than 10. While true is like a forever loop in Go. And then you also have a do while loop, which there isn't really anything similar to this in Go. But the trick of a do while loop is that it's always guaranteed to do things once. So if I started this at 100, it's still going to do it once before it has a chance to check the count. So that's the difference in the do while loop, is that it's guaranteed to fire once, and then it checks the condition at the end as opposed to at the beginning. And Go doesn't have anything like this. Turns out that you never ever need these. I mean, they're there so people use them, but Go proves that you don't actually need them to have a programming language. What did I miss? Oh, right here. No. So notice it only did the I am a loop once, even, um, I mean, it did it once, even though it looked like the count was too big to start, but that's because it doesn't check the count until after it's done it. So for loops, while loops, and do while loops in C++. And then I don't really have a, well, I can show you the one other kind of loop. I don't know if you might have had enough. There's one more kind of loop, and I can show it to you unless you feel like you've had enough. Um, then these are the core loops. So I'll show one to you. Um, I call it a for each loop. So, but let's say we had a string. I'll just call it stuff, and I will put in there just stuff. No, let's say like apple 1, apple 2, banana. So the last kind of loop, which hopefully works here, it's a little bit like a range loop, a little bit like a range loop. So we can say for each single character that I'll call C that I get from stuff. So this is kind of like I'm ranging over stuff for the individual characters. We've never used anything like an individual character in Go. It does have something like it, but this is the last kind of loop. So it's like a range loop. I'm ranging over stuff, which is a string, and I'm pulling off one character at a time. So what that'll do is it'll print off the individual characters of this string up and down, followed by end lines. So it's a bit like a range loop in the Go language. I call it a for each loop. So for each character that I'll refer to as C, as I range over stuff, do something with the single character C. So there's the 1 space A P P L E. That's the for each loop executing over there. Yeah, no, that's kind of it's a fun effect. It's so easy to do too, right? Just that 2 lines of code basically to get that effect. That probably is a pretty good that's a pretty good dose of C++, I suspect. I'm happy to answer more, but um, make sure that you give yourselves some time to absorb a little bit. Yeah, so we certainly can. That's a good idea. So next week we'll do Tuesday. I have to do a normal class so we can get through the last lab. But I'll probably do what I did this week and probably work through the most or all of the lab on Tuesday, and then after that we can talk about C++, and then Wednesday, no doubt. If you come in on Wednesday, there won't be many people around, and we can do that. And then also on Thursday, we should have tons of time. So, yeah, we can do all those things. I'm happy to do it. Okay, I think then that's a calling it an end to the session. Everybody have a good weekend, and we'll see you on Tuesday at 2 p.m. If you have questions, you can always email me. Um, Otherwise, take care, and I will see you next week.